Hey guys, so this is an example video of the chain rule and the quotient rule together, and specifically this is a step-by-step example. So step-by-step is a new type of example video I'm trying out, so I'm really curious to hear what some of you think of it. So like I said, new example type, it's going to be slow and more worked out details. So some of you have kind of said that you don't like that I plow through the examples, so I want to kind of throw in some other variety. So just FYI, if you find that some of the examples go a little bit too quickly, the lecture videos usually present other examples in a much more slowed down manner and really do a deep dive into some of the theorems. So if you find the examples are a little too fast, I would also recommend checking out some of the some of the lesson videos. Okay, so for this example, I'm going to just be doing this example. This is it. I'm just going to be taking the derivative of this and kind of going through all the work. So this one is going to require that we use the quotient rule, so I've got that listed here. And then as we're working through the quotient rule, we're going to end up running into the chain rule. So just to be clear here, so this one's going to be my f of x, and this one's going to be my g of x. So I'm going to color code them as I start this first step here. And notice that with the g of x, so it would be crazy to multiply this together 6 times. I mean, I see sometimes people do it, but it's just so much work and it's just asking for like an algebra error, right? So it's much easier just to kind of work with the chain rule in this case. Okay, so let's get this party started. So first things first, I have to take the derivative f prime of x of this. So thankfully that one's not too bad. So that's just 3, and then I leave the g of x alone. So that's x to the third plus 5 to the 6th, okay? And then subtracting from there, so let's see, oops, let me put that in the white color. Okay, so now I leave my f of x alone, so let me write that part out, so that's just 3x. And now here's where I've got to use the chain rule. So now I've got to take the derivative of g prime of x, so I've got to take the derivative of this guy. So if we really want to kind of break this down for a moment, let me just write that on another slide. So I just want to take a moment to just break this part out. So looking at this function, the outermost function is this thing to the 6th, and then the innermost function is this part here. So when I take the chain rule, what I want to do is I always want to start from the outside and work my way in. That's the way I prefer to do it. Some channels might do something different, but that's my preference. So what I'm going to do first is take the derivative of this outside function, so something to the 6th. So I use the power rule, so I bring the 6 down. So bring the 6 down, and then I'll subtract 1 from the exponent. But then in doing this, I leave the inside intact like this. And now I multiply this by the derivative of the inside function. So this is just going to be 3x squared. Okay, so now that I have this, I want to work this out in just a little bit more detail before I go plugging it into my derivative. And sometimes when you're getting into these really nasty derivatives, you might find breaking out the separate details is very, very helpful. So now if I try to multiply all this together, I get 18 x squared x cubed plus 5 to the 5th. So that's what I want to plug in now. So that is what's going to go in right here. So that was 18 x squared x cubed plus 5, all of that to the 5th. Okay, so now I take all of that's just the numerator, right? And now I take all of that and I divide that by g of x squared. So that's going to be x cubed plus 5 to the 6th. And then I'm going to put square brackets around this, and I need to square this. So now we're going to simplify this all the way through, and we're going to be really strategic. So let me make some space. So sometimes I see people get a little tripped up about what do you do now with all these things, this to the 6th, this to the 5th, what do you do with all this? So try to leave these alone. I usually try not to multiply things out unless I feel like I absolutely have to. So we're going to have to be clever, but we're also going to try to be a little lazy. So sometimes cleverness and laziness go together. So I'm going to leave this like x cubed plus 5. I'm going to leave those terms alone, but I'm going to kind of work on the stuff on the outside. So let's go through this. So I've got just this 3 times this. I can't distribute the 3 in, that would violate the order of operations. So I just have to leave this first part as just 3x cubed plus 5 to the 6th. Now, this part here, I can do the 3x times the 18x squared, right? So that will be 54x cubed. But then once again, what I want to do is I want to leave the rest of this intact like that. And then in the bottom here, so I can multiply 6 times 2. So what I'll get then is, let's see, this will be, oops, let me get rid of the square bracket. This will be x cubed plus 5 to the 12th. Okay, so now I notice a few things I can do here. And this is where the algebraic creativity starts to come in, by the way. So notice I've got this x cubed plus 5 to the 6th, x cubed plus 5 to the 5th, and then this x cubed plus 5 to the 12th. There are several ways that you can handle this, but ultimately what we need to do is we need to cancel out as many of these as we possibly can. And the most that we could cancel out would be 5, right? That would be the lowest number. So options in how you can do this, you could just straight up factor this thing out, which is how I'm going to do it. But alternatively, what you could do is you could just subtract 5 from each one of these and then just kind of sort it out that way. But I want to show you a little bit more of a creative way to do this. So, you know, if you don't like this explanation, then try it the other way. Like I just said, just subtract 5 from each one of these and see what you get. But now let me make some space. And so I'm going to factor just this guy here. I'm going to factor this out, okay? So I've got x cubed plus 5 to the 5th. So I'm factoring that out from the rest of this up here. So as I factor that out, this is going to leave me with 3. Then this 6, now if I subtract 5 from that, that just leaves me with one more factor of this. So this will be 3 times x cubed plus 5. And then minus 54x cubed. All of this over x cubed plus 5 to the 12th. Okay, so this is going to allow me to do a few things. So now that I've factored this out, I can really safely cancel this out with this here. So what I mean is I'm going to factor this out. This 12, I'm going to subtract 5 from it. So now let's see where I'm left, where I'm at. So let me make some space. So now I've got y prime equals, so this is just going to be, so all of that canceled out, so I'm left with 3 times x cubed plus 5 minus 54x cubed on top. And then in the bottom, this is x cubed plus 5 to the 7th. Okay, so now what I need to do as I look at this, I'm not done, right? So notice you got x cubed here and x cubed here. So you're actually going to have some like terms you can cancel out. So the next thing I've got to do is I've got to distribute this. So I think I've got just enough space to do that. So this will be 3x cubed plus 15 minus 54x cubed, all of that over that x cubed plus 5 to the 7th. Okay, so now we're in the home stretch, so I'll make some more room. And so now collecting my like terms, this is negative 51 x cubed plus 15 over x cubed plus 5 to the 7th. Now, there are a few other things I can do to this, so I want to just compare this answer. I want to show you what I got when I plugged this into a derivative calculator. Okay, so there it is. So I've got negative, and then this is 3 times 17x cubed minus 5 over x cubed plus 5 to the 7th. So it looks like we got something different. And so this is why I always caution you, like you have to think when you are using these derivative calculators, because they aren't going to just do exactly what you did. So sometimes there's several different equivalent answers. And so you have to kind of now think through the details of this. So as I look at this to this, I'm like pretty close, right? I'm off a little bit by signs and I factored something out. So you might be able to, like the big thing with this is just to figure out, can you actually manipulate this to make it look like this? Which in this case, it's a simple manipulation in that I can just factor out negative 3. So if I factor out negative 3, then I get 17x cubed minus 5 over all that other stuff. And then the only other thing that they did in their calculator was they moved the negative from here just to the center of the fraction, because it doesn't matter which place it goes. So if it's here in the center or if it's up here, those are equivalent, because, just as a reminder, 3 equivalent fractions, negative a over b is the same thing as negative a over b. So notice where that sign is, and that's the same thing as a over negative b. So those are 3 equivalencies. So that's the only other thing that you'd have to do. From my standpoint, this would be good enough. This would also be fine. So people just go kind of different directions with it. So this is always like the tricky part of working in a calculus class, and forcing yourself to kind of go through and do this manipulation will make you a much stronger student. I realize it makes you a much more frustrated student, but like the more you practice this, the easier it starts to get. And then you start to look at solutions and you kind of know whether or not you got it right, you know, might mod some simplification. So that's it. If you liked this format of a video, this step-by-step, let me know in the comments. I am deciding whether I want to make more examples that are like this. So I always read your guys' feedback. It's super helpful for me. So thanks for watching, guys. Hopefully I'll see you again.